Welcome back to our Coding for Chemistry series. Previously, we wrote Python code to compute the molecular mass of methane. Today, we're going to improve that script dramatically by learning an important programming idea, functions. And by the end, we'll have a reusable tool for calculating molecular masses of hydrocarbons. Let's dive in. 1. Expressions and statements. Quick review. Let's warm up with a foundational idea. In Python, an expression is anything that has a value. Numbers like 2, -0.005, strings like hello, or even something like the math expression x plus 3. If I write atomic mass equals 15.99, both atomic mass and 15.99 are expressions because they each represent a value. But the whole line together, atomic mass equals 15.99, is a statement because it does something. It stores the value 15.99 into the variable. A program is simply a list of statements that instruct the computer what actions to perform, calculating, printing data, saving data, and so on. 2. The repetitive approach. Last time, we calculated the mass of methane. Extending that to ethane, propane, and butane might give you something like this. Constants, mass underscore C equals 12.011. Mass underscore H equals 1.008. Methane, num C equals 1, num H equals 4, mass CH4 equals num C times mass underscore C, plus num H times mass underscore H, print mass CH4. Ethane, num C equals 2, num H equals 6, mass C2H6 equals num C times mass underscore C, plus num H times mass underscore H, print mass C2H6. And you repeat the same pattern again for propane and butane. It works, and running the script prints 16.043, 3007, 44097, and 58.12999999995. The tiny rounding issue in butane is from floating point precision. Python floats behave like C, C++, double, Fortran Real 8 or a Real 64, etc. with around 15 to 17 digits of accuracy. But the bigger problem is this. This code is repetitive and hard to maintain. Time to fix that. 3. Introducing functions. In programming, when you notice yourself repeating the same structure of code over and over, that's a big clue that you should use a function. A function collects several statements together and gives them a name. Whenever you need that same computation again, you call the function instead of rewriting everything. This is how we can rewrite our molecular mass code. Def molecular mass, open parentheses, num of carbons, comma, num of hydrogens, close parentheses, colon, mass C equals 12.011, mass H equals 1.008. Num C equals number of carbons, num H equals number of hydrogens. Mass equals num C times mass C plus num H times mass H, print mass. Return mass. Then call it like this, molecular mass, open parentheses, 1, 4. Molecular mass, open parentheses, 2, 6. Molecular mass, open parentheses, 3, 8. Molecular mass, open parentheses, 4, 10. Same result, but now clean, reusable code. 4. How to define a function, the details. Let's break down what's actually happening inside a function definition. 1. The def keyword. Every function definition in Python starts with def function name, open parentheses, parameters, close parentheses, colon. The name follows the same rules as variable names. Inside the parentheses, you list parameters. These act as placeholders for the values your function will receive. Don't forget the colon at the end. 2. Indentation matters. Everything inside the function must be indented. Python uses indentation to define code blocks. If you're using an IDE like Spider, the editor will automatically indent after the colon. If you're writing in a plain text editor, you'll need to press the tab key yourself for indentation. 3. Parameters versus arguments. This is an important distinction. Parameters are the variables in the function definition. Example, num_c, num_h in molecular mass function. Arguments are the actual values we pass when calling the function. Example, molecular mass open parentheses 3, 8. Arguments are 3 and 8. 4. The return statement. A function can send a value back using return. As soon as Python hits a return, the function stops running immediately. If there is no return statement, the function returns none by default. 5. Function must be defined before it's called. This will generate an error. Foo, open parentheses, close parentheses. Def foo, open parentheses, close parentheses, colon, print, open parentheses, quote mark, hello, close parentheses, colon. Because Python reads the file from top to bottom. It doesn't know what foo is yet. But this works. Def foo, open parentheses, close parentheses, colon, print, open parentheses, quote, hello, close parentheses, colon, foo, open parentheses, close parentheses. 6. Built-in versus user-defined functions. Our molecular mass function is user-defined, but Python gives us many built-in ones. We've already used the built-in function print many times. It takes one or more arguments and displays them on the screen. Now let's take our program a step further and explore return values more deeply. Our current function prints the mass directly, but since it already has a return statement, we can make it do something much more informative. Let's modify it. First, start by commenting out the print line, #printmass. Second, now let's build a new string named molic and return it. Molic equals c plus stir of num_c plus h plus stir of num_h. Molic plus equals plus stir of mass, return molic. Here's what's happening. The plus sign between strings is called the concatenation operator. It joins two strings together. The function stir converts a number into its string form. For example, if num_c equals 2, then stir of num_c becomes 2, a string, not a number. Therefore, c plus 2 becomes c2. If num_h equals 6, we eventually form c2h6. The second line uses an augmented concatenation operator, plus equals. Its syntax is string 1 plus equals string 2. And it simply means string 1 equals string 1 plus string 2. This works just like it does in C++ string concatenation, so if you've coded in C++ before, the behavior will feel familiar. So, if the computed mass is 30, the final string stored in molic becomes C2H6 equals 30. And this is the value returned by the function. Third, updating the script body. Add print molecular masses. Print molecular mass of 1 and 4. Print molecular mass of 2 and 6. Print molecular mass of 3 and 8. Print molecular mass of 4 and 10. The first line lets the user know what the following output represents. Each call prints a full message of the form CXHY equals molecular mass instead of just raw numbers. This makes the program's output far more readable, descriptive, and user-friendly.
5. Why functions matter.
Functions help us avoid repeating the same code. organize our logic, make programs easier to read, allow future extensions, reuse the same computation with different inputs. In other words, functions make you a more powerful
and efficient coder.
So today we learned what expressions in statements are, how rewriting the same code repeatedly is inefficient, how to clean up our molecular mass script using a function, how function definitions work in detail, parameters, arguments, indentation, return values, and call order. The difference between built-in and user-defined functions. In the next episode, we'll enhance our program by taking user inputs so users can calculate the mass for any chemical compound. Stay tuned for more chemistry plus coding.